Let's talk about a board that's not just another evolution, it's a full-on revolution for makers. It's the Arduino UNO Q, and it does something that's always been a huge challenge. It combines high-performance computing with super precise real-time control. We're going to break down exactly why that is such a massive game changer.
All right, so to really wrap our heads around why the UNO Q is such a big deal, we've got to start with a fundamental problem it was designed to solve. It's a core dilemma that developers have been bumping up against for years.
You see, in the world of electronics, you've pretty much always had to pick a side. Did you need the raw computational horsepower of a computer, or did you need the lightning-fast, totally predictable reflexes of a microcontroller? For the longest time, getting both of those in one simple, easy-to-use package, well, that just wasn't really a thing.
So on one hand, you've got your single-board computers, your SBCs. Think of these as the brains of an operation. They run full operating systems like Linux, and they're awesome for heavy-duty tasks like AI or computer vision. But here's the catch. Their timing can be a bit unpredictable. They aren't deterministic, which means you can't guarantee an action will happen at an exact millisecond. Then on the other side, you have microcontrollers, the MCUs. These are the fast reflexes. They give you incredibly precise, real-time control, which is absolutely essential for things like motors and sensors, but they just don't have the processing muscle for complex thinking.
This is where it gets really exciting. Arduino looked at this whole situation, this constant trade-off, and basically asked, why are we forcing developers to choose? Why not just have both?
And this is their answer, the Arduino UNO Q. It's a true hybrid, a dual-brain platform that literally fuses a powerful single-board computer and a real-time microcontroller onto a single board. And maybe the best part? They did it all while keeping that classic, familiar UNO form factor that everybody knows and loves.
So you might be asking, how does this dual-brain system actually work under the hood? Well, let's peel back the layers and meet the two distinct processors that give the UNO Q all its power.
Now, what's so brilliant here is how cleanly the jobs are divided. On the left, we've got the microprocessor, or MPU. We're calling it the thinker. This thing is a beast, a powerful Qualcomm chip running a full Debian Linux OS. Its job is to handle all the heavy lifting, AI models, video processing, you name it. Then on the right, we have the microcontroller, or MCU, the doer. This is a solid ST microchip running a specialized real-time operating system. Its one and only focus is doing what Arduinos do best, giving you that guaranteed, precise control over sensors and motors.
Okay, so we've got two brains. They're running two totally different operating systems. This is the million-dollar question, right? How in the world do you get them to talk to each other and work like a single, cohesive unit?
The answer, it turns out, is in the software. Arduino created something totally new for this called the App Lab. It's the magic glue, the development environment that was built from the ground up for this dual-brain setup. It's what lets you write Python scripts for the powerful Linux side and your traditional C++ sketches for the real-time side, and have them all communicate perfectly within a single project.
At the very heart of all this is a communication layer they call the bridge. It uses a clever trick called a remote procedure call, which is really just a fancy way for two different programs to chat. So let's walk through it. Your Python script running on the Linux thinker decides it's time to turn a motor. It just makes a call through the bridge. That bridge seamlessly zips the command over to the C++ sketch living on the real-time doer. The MCU gets that command and boom, it executes it with millisecond perfect timing. It's just a super elegant way to turn a high-level thought into a precise physical action.
So once you have the power of a computer brain and the reflexes of a microcontroller brain working in perfect harmony, a whole new category of really sophisticated projects suddenly becomes not just possible, but actually pretty accessible.
The most obvious place to start is on-device AI. That Qualcomm processor has specialized hardware inside that's literally built to chew on visual data. This makes it perfect for running some pretty hefty computer vision models right on the board itself, without ever needing to connect to the cloud.
And this little face tracking car is just a brilliant illustration of the whole concept. So the MPU, the thinker, is doing all the hard work, right? It's running the AI model on the camera feed, finding a face, and calculating which way to steer. But, and this is the important part, it doesn't try to control the motors directly. Instead, it sends a simple, high-level command like turn left over the bridge. The MCU, the doer, receives that simple command, and its whole job is to translate that into the super precise electrical signals needed to make the wheels turn perfectly. The intelligence and the control are perfectly divided, each doing what it does best.
And don't think for a second this is just for hobby projects.
The exact same principle, separating high-level intelligence from low-level real-time control, is what allows this architecture to scale way up for advanced robotics and even demanding industrial automation.
Let's look at how this plays out in the real world. For some advanced robot, the Linux MPU can run complex pathfinding algorithms, while the MCU just handles the stable, high-speed joint control. In a factory, the MPU can manage all the secure networking and data, while the MCU reliably interfaces with all the heavy machinery. And to make all of this even faster, the App Lab has these pre-built software modules called bricks, which let you just drag and drop complex features, like an AI model or a web dashboard, right into your project.
So what does this all mean for Arduino and its massive community? Well, the UNO Q isn't just another board to add to the pile, it really signals a major strategic shift for the whole platform.
You know, I think this quote from David Groom at Make Things just sums it up perfectly. By integrating a full Linux computer, Arduino is taking a massive leap from its microcontroller roots. They're creating a tool that's ready for the next generation of robotics and the Internet of Things, finally closing that gap between high-level computing and real-world control.
This board really does remove that old compromise between power and precision. It gives you both, right in one package. So, the only real question left isn't what the board can do. It's with this kind of capability in your hands, what new ideas will you bring to life?